Deep Learning Visual Demo. This tool helps us understand the various steps involved in deep learning by providing a walkthrough of a couple of simple examples. Deep learning is a specialized branch of machine learning centered around training neural networks with multiple layers to autonomously learn hierarchical data representations. This technique utilizes deep learning frameworks like TensorFlow, PyTorch, and Keras to efficiently implement complex algorithms. The process involves several steps: acquiring a dataset with input features and output labels, defining the model architecture and connections between layers, compiling the model with loss functions, optimizers, and evaluation metrics, training the model using backpropagation and gradient descent to adjust weights and biases, and ultimately using the trained model to make predictions by passing inputs through its layers to obtain corresponding outputs. Deep learning has shown tremendous success in various domains, including computer vision, natural language processing, and speech recognition, significantly advancing the capabilities of AI systems. This tool will help us understand the steps involved in deep learning end-to-end. Let's explore it. This tool is an extension of a tool we covered earlier, where most of the elements were hard-coded. Here, we can select and try a number of things to train the neural network. So first, you can select one of two examples: the exclusive OR example and the height-weight example. Next, the tool displays the data associated with the selected example. Under model architecture, we have two layers of the network, where the user can select the number of neurons in each layer and one of the 6 common activation functions. Here we have the training section, where the user can select the learning rate and the maximum number of epochs. Next, we have the run button, which, when pressed, will start the learning process by updating the epoch number and loss. Finally, the user will be able to predict the output against the selected input. Let's first see how the epochs limit affects the training and the prediction. We're going to use the default value of 200 and click Run to complete the training. If we now predict the output for the input 1, 1, we should see a number close to 0. By clicking Predict, we see that the output is 0.068, which is very reasonable. Now let's change the max epoch count to 1000. And click Run and wait for it to finish. We should now expect a more accurate, or closest to 0, output for the 1, 1 input. So press Predict. And we guessed right, the output is 0.008, much closer to 0 than the previous example. Now let's reset the max epochs back to 200. Next, we can experiment with the learning rate. If we choose a very small learning rate and the number of epochs is not sufficient, we may get a poorly trained model because the loss function may not reach its minimum value. Let's try it by setting the learning rate to 0.001, which is the minimum slider position. Run the training and wait. Now let's click Predict. Notice that the output is not close to 0, proving our hypothesis. If we now choose a relatively high value for the learning rate, the system may converge to the minimum loss very quickly, or it may overshoot. Let's try it. So we can set the learning rate to 0.4, or the rightmost position of the slider. Click Run and then wait. Once done, we click Predict, and notice a good convergence and accurate prediction. Let's refresh the page to reset the system. Next, we can try changing the units, or the number of neurons, of layer 1. If we change the units from 4 to 2, we should expect a less accurate model because there will not be enough weights to tune. We press Run and wait until it's done. Note the loss value, which is quite high. We try predict and notice that the output is not as accurate, just as we expected. Now, if we repeat the experiment with a large value of units for layer 1, so let's say 6, and we run the training, when we press predict, we notice a relatively more accurate output. Similarly, you can experiment with the activation functions for each layer 1 and 2 by selecting one of the 6 functions provided. This covers how this tool can be used to understand the different steps involved in deep learning. Feel free to try any combinations of units, activation functions, learning rate, and max epochs on the exclusive OR example or the height weight example.